Hello everyone, welcome back to the next lecture of our blockchains course. We've been looking at Hyperledger Composer. We went through some of the concepts in Composer, how you can easily develop an application on top of Composer and how that connects to a Fabric network. So in this lecture, we're going to talk about how you would manage your Composer network itself. How do you build it up? How do you manage it? What are the key concepts in managing a network? And how Composer makes it easy for you to manage your network. Right? Some of the concepts in Fabric in terms of governance of the network, in terms of channel administration and all, are made easier for you in Composer. So the main role that is going to be using this network administration is the network service consumer role. So as I mentioned, there's someone who is going to be governing the network. That's one role. This governance, again, I'm saying one role, but it could be multiple organizations that all serve this role. They're going to be managing who joins the network, who's participating and so on, channels and all that. The network service consumer is going to be operating a set of peers. So within an organization, let's take each organization will have a network service consumer. They're going to manage the peers, the certificates, set up the network, join the channels and so on. Right? So that's the network service consumer. So that will be the main role who will use these functionalities provided by a Hyperledger Composer. We looked at the business service provider before. They were the ones who were developing the applications. And the other consumer is going to be the ones who are hosting applications and building applications on top of the network that is provisioned. So that's the business service consumer role. So these are the two roles who are going to be using some of the features that I'm going to be talking about in this lecture. And like I mentioned, although we've abstracted these into roles, one organization could play multiple of these roles. So what are some of the key concepts here for your network administrators? Let's start with the network service consumer. So this is a person who's going to be setting up the set of peers, maybe managing the membership of users in their organization. So what are some of the things that they're going to do? The business service provider has developed smart contract logic. So they're going to be packaging that smart contract logic in some way, and we're going to call that the business network archive. So we'll talk about what that is, how this whole thing is getting packaged up. So that's the business network archive. Once that is packaged, it's going to get deployed onto the Fabric network. So I mentioned that Composer runs on top of Fabric. So once you've packaged up what your business network specification is, you're going to deploy that onto the Fabric network. So each peer will get a copy of that. There is a Composer runtime, which is a Chaincode container. So it's a special container that Composer implements. And this container is going to interpret the business network definition or business network archive, all the assets, participants, transactions that you have defined for your network. So that is deployed onto the Fabric network. Now that talks about the smart contract logic itself. Apart from this, the network service consumer is also going to create what is called a connection profile. So this connection profile is going to talk about what the network is, how should users connect to this network, and it gives you details about who are the peers, who are the orderers, what channels. It gives you all of that information. That is the connection profile. Now that's the network service consumer. They're going to define the smart contract logic, deploy it on the Hyperledger Fabric peer or peers, and they also create the connection profile. Now end users, these are the business service consumers. These might be applications, it might be individual end users who are going to be invoking transactions that are defined in these smart contracts. They all, of course, need some notion of identity, right? So there is a notion of identity, so they're going to be issued identity. So the end users have, let's say, certificates. Composer gives you easy way for you to create all of that, abstract away the notions of certificates for you. You don't have to deal at that level. You only have to deal with the level of, let's say, a member and identifiers for that member. Then the business service consumer is also going to host the application logic. So this could be a REST interface that end users can invoke to say, I want to perform this transaction on blockchain. It could be a business application logic that runs there. This is not the smart contract logic, but any application logic that you want to run on top. And it could also have integration logic with other systems that you work with. And this whole application is going to connect with the Fabric network and the smart contract that you've deployed. How does it connect? There are two pieces of information that it needs to connect. The first piece of information is the identity of the user performing the transaction. So that is the consumer identity. So that needs to be there. You also need to have the connection profile. So that's the connection profile I talked about. So you need the identity and you need to know which peers to connect to, which channel and so on. So think of it in the the equivalent in the Fabric domain is whatever information is there in your SDK. For your Hyperledger Fabric client, you need to provide information. You need to have a wallet that has your private key for signing a transaction. That is your consumer identity. You need to know which peers to connect to, which order, which channel to connect to. All that is known in your Hyperledger Fabric client. So the same information is going to be packaged up into a connection profile and a consumer identity. And together, this is going to be called a business network card. So this business network card will be available with each end user. They'll be using their personal card to connect with the blockchain, authenticate with it, sign and submit transactions to blockchain. And the blockchain, of course, will validate and accept their transactions. So that's the overall flow. So we're going to look at some of these concepts in more detail. What is the business network archive? What is the business network card? So all of these, how is the identity created? So all of these we're going to be talking about in the course of this lecture. Now let's talk about the business network archive. So this is the BNA file. So the BNA file consists of the following, right? All of these we talked about in the previous lecture. It includes the model files. It's called the CTO files. So this includes your data elements. So this is the assets, participants, all of them are defined in your model files. Then there is the transaction processors. This is your JavaScript function which captures the business logic to be placed in your smart contracts. So this is your transaction processors. You can define your access control lists and any static queries. So all of these are captured in different files. And in addition to all of these files, you can also add any documentation you want. So let's say someone else queries your contract business network, they can understand what this application is doing. So in plain text, in actually a .md file, you can define the documentation for your application. All of these are packaged together into a BNA file. And that is going to be your business network or the application that you've defined on Composer. And this significantly simplifies the deployment of blockchain between environments. So you can package this in tar, in a WAR file, EAR, and so on. So it really, across different environments, depending on what you are comfortable with, all of the BNA file can simplify the deployment for you. And it's possible for you to create BNA files from the playground itself. So while you're playing with it, you can create some sample models in the playground. You can store that as a BNA file, load it up later, and modify it. Or you can take it to a different application and use it there. And you can build something in the playground and actually take that to a real network deployment with Fabric and use it there. Right? So you can build this from the playground, build it from file system or through an NPM module. So all of that is possible. That was a BNA file. Now coming to the connection profile. Right? So this I mentioned is capturing the network configuration itself, the peers, order, channels, and so on. So how is this done? You need one connection profile per channel on your Fabric network. So depending on the number of channels, you'll be creating as many connection profiles. For the web-based simulation, you can not have the connection profile. All you need is your BNA file. You can just say these are my models, these are my transactions and access control rules. You don't need anything else because it's not actually connecting to an actual channel in the backend. It's only meant as a playground. You are required to enroll users into the Fabric network and it has to have a Fabric identity for each of your Composer participants. So we'll talk about identity in the next slide. But the connection profile is mainly about the peers and the channels used. So if you look at this example here, it says these are the orderers, this is the MSP, this is the certificate authority, these are the peers in this network, and it gives you the key value store directory. So all of this is captured in your connection profile. And here's an example JSON which gives you all of these things. The same attributes is captured as a JSON here. It currently is used only by Composer, but in future it's also possible for Fabric to also consume this. But right now Fabric doesn't consume this as yet, but it could be in the future. So the other thing you need, apart from knowing which peers, orderers to connect to, you also have to have an identity on blockchain. Again, Composer makes this easier for you. You can create network participants with an identity to connect to Hyperledger Fabric. So this is issued as a Hyperledger Fabric user ID and secret, and it automatically wraps it in a certificate whenever you're using it first time. Right? So the certificate creation is taken care of for you, and this is together with the connection profile. it is packaged into a business network card and supplied when the client application is connecting. So like I mentioned, every client trying to connect to the blockchain network has to have this business network card that has both this identity as well as the connection profile. Now, the composer participant to Fabric identity mapping. So when I said you're creating a new user in Composer, we automatically create the ID for you in Fabric, and the certificate is also generated for you. The mapping between the Fabric ID and the Composer participant is also stored as a transaction in the identity registry that the Composer runtime maintains. So this is also maintained in blockchain also, right, in a decentralized fashion. Only the business service consumers have a Fabric identity. End users, for instance, can be abstracted away by application logic, and they might just have an application identity. So they might not have a identity themselves on blockchain. Only the business service consumers would have an identity. So the end users who do not have an identity will be using the business service consumers as a proxy to connect to Fabric. And the identity can be managed from any of you can manage it from Playground, you can manage it from JavaScript. There are REST APIs, and there are also command line functions or command line utilities that you can use to manage your identities. So you can test your connection, you can issue an identity, you can bind an identity to a participant, and so on. So you can revoke an identity. All those are possible. I mentioned the business network cards, right? So this is a private card that everyone needs to have that combines the identity with the connection profile. So it's packaged together, and that is what you will use to connect to the network. So this is kind of what is captured in the Fabric SDK when the client is connecting using the SDK. So it needs everything that you need to connect. And you can think of this as an ATM card. The ATM card, for instance, if you think about it, the way we use our bank cards, it has your identity also in it. It also has the fact that you are connecting to a particular bank, right? You are a customer of, let's say, SBI. And SBI issues a card to you that has information both about the network, the fact that you are a customer of SBI and it's connected to a network of ATM. So I can take it to a HDFC ATM also and use my SBI card. And it has my identity also. So it has both the network information as well as the identity information. So that's exactly what this business network card is. Think of it as an ATM card. And you can manage these cards to do all sorts of transactions. You can create, delete, import, and you can manage multiple of these cards through command line as well as Playground. Then you're using these cards to connect to Fabric from whether it's Playground or command line or from your application, your JavaScript. You'll be using these cards to connect. Right. So here is just a small example of how you would connect to Hyperledger Fabric using a business card. Composer helps you integrate with existing systems of record, and it helps you create domain-specific APIs. So this is the automatic generation of APIs from the model files that you are creating. So based on the assets you've created, Composer automatically can generate APIs for you. And it uses the Loopback framework for this. So any application, any other system of record that leverages Loopback can be integrated with this. And it also provides you extensive test facilities. And with Loopback, it also creates a Swagger API document for you. So you can go to Swagger and open up your set of APIs and perform your REST queries or REST invocations. And this whole thing is secured using JS Passport, which is a very popular tool, and it has over 400 options for authentication. It provides a backend integration with any Loopback compatible product. Today we have connected it with Integration Bus and API Connect. So and actually Node-RED. So we'll talk about that. So here's the example of exploiting Loopback. So the integration. So if you take IBM Integration Bus, it has a Loopback connector. So we have implemented Composer capabilities as a Loopback connector. So it can take a sample file from SAP or MQ, and you can connect that to your Composer transactions. So you can easily map data from, let's say, a CSV file to a JSON model definition in Composer. Likewise, we also have a Loopback connector for Node-RED, and it gives you pre-built Node-RED, pre-built nodes available for Composer. And you can use that to connect to hardware devices. Maybe these are IoT devices that you can connect to. APIs and other services. And this is directly available from the Node-RED UI. You can install it directly from there. It's very, very easy to use. This is going down a level of detail to see how Composer actually maps this into Fabric. So I told you Composer runs on top of Fabric. So how does it do it? So the Composer client itself is actually going to be talking to a Fabric client, which is going to be using Fabric SDK to connect to a special chain code that Composer executes. So this chain code has logic to start up a Java virtual machine inside Fabric, inside the peer. And this Java virtual machine is going to be running a JavaScript runtime. And what this runtime is going to do is it is going to interpret any smart contract logic you have placed there. So maybe explaining it from the other way around, all of these components are pre-deployed when you're deploying Composer. When you're deploying a smart contract, all you're adding is this end-user JavaScript code. These are your transaction files, your model files. All of that are getting deployed as a smart contract onto Hyperledger Fabric. A Composer runtime is going to interpret that JavaScript logic. And all of this is contained within a chain code that's connected to this JavaScript peer. And there is, of course, it connects to the peer. This chain code connects to the Fabric peer and connects to the ledger from there. So this whole runtime is how your code that is written in a higher level business abstraction is getting interpreted as part of chain code execution in Fabric, and is decentralized in its execution across all the nodes in the Fabric network. And each business network that you are defining will be deployed in its own chain code container. So it's isolated in that way. And it has a static piece of Golang chain code that is going to be executing this. And it's possible for you to look through Docker logs and browse these containers to view any diagnostic information. So if something fails or something, you can quickly go look up Docker logs to see why it failed, and you can debug from there. And the embedded chain code, this chain code itself is not exposed as an interface to the outside world. So this is actually integrated into Fabric, as in it's deployed into Fabric, and doesn't have a immediate interface to the outside world. So the way you connect to it will be through the Fabric client and the SDK to connect to this chain code. So Composer is in active development. Just 2 or 3 months back, end of 2017, we actually released the first version, the V1 version, the production version of Hyperledger Composer. And there are a lot of improvements that are still being planned. And they are active there's an active discussion in the community about prioritization of these improvements. And there's active development going on to improve some of these features in Hyperledger Composer. And it's an open community. They run a call every 2 weeks, so anyone is invited to participate and contribute to the community. And just like Hyperledger Fabric, they have a very active Rocket chat. So they have an online chat forum where you can go ask doubts, you can help others, you can answer questions for others. There's also a Stack Overflow where people ask questions and people answer there as well. And I would encourage all of you to get involved. Right? So it's a great way for you to start building your first blockchain applications. Here are some quick links. You can go look up Composer. This is the top level page for the GitHub in Composer. You can go through the code. You can go to the playground where you can quickly try out creating an application yourself. So for the fun reading section of this course, for this lecture, how do you build a first application using Composer? There's a very simple tutorial that you can follow. It's in DeveloperWorks in IBM. So you can check that out. And apart from that, I think I would like to highlight 2 other Hyperledger projects that could also be very useful for you in your development journey, right, as a developer. One is Hyperledger Cello, right? Cello is a Hyperledger project that aims to bring as a service deployment model for blockchain ecosystem. So currently, I think they're supporting only Fabric, if I'm not mistaken. And it helps you reduce the effort required to create, manage, and terminate blockchain networks. So it makes it very easy for you to join a network, create a channel, and so on for Fabric. Hyperledger Explorer is another very interesting project. It gives you a good visualization tool for you to look at your blockchain itself. So you can query the blockchain, you can find out what transactions are there, you can invoke, deploy, look at blocks of transactions, and it has a neat visualization. So you can follow transactions around from one transaction to another in a nice pluggable visualization framework. So I would encourage you to look at both of these projects, and for any application you might develop, you could use both Cello and Explorer. Cello will help you set up the network and manage it. Explorer will help you visualize what's happening on your network and monitor what transactions are going on. I would encourage you to explore at least these two projects. There are at least a half a dozen other Hyperledger projects, and we'll also be talking about some of the other blockchain platforms later in the course. Okay, with that, thank you. Thanks for your time.